Hello, it's us with Hamburg's ITS projects explained in short. Let's have a look at the test track for automated and connected driving. Hello, it's us with Hamburg's ITS projects explained in short. Let's have a look at emergency vehicle prioritization. Hello, it's us with Hamburg's ITS projects explained in short. Let's have a look at traffic light forecast, the cycle traffic counting network for Hamburg, and automated traffic volume detection.
A traffic information management system pilot project is being developed by Siemens that can be used by operations centres to have a holistic view of the city's current traffic situation. It uses several sources like the AVME to aggregate data from traffic disruptions, planned events like construction and bus schedules to visualise everything onto one digital roadmap. Users like traffic control centres, bus operation centres or the Port Authority can use this map to receive real-time information regarding traffic irregularities. If there is a road accident, they already have decisive data and can respond immediately. And if there are other obstructions like construction, they would know how to redirect traffic in the most optimal way. Better information means better traffic, and better traffic means less pollution. And standardized APIs create transparency.
Hamburg is getting smart with LoRaWAN. At Stromnetz Hamburg, we are helping to turn our city into a smart city and supporting the digitalization process in a wide range of sectors. LoRaWAN is an international network protocol used for wireless data transmission, similar to Wi-Fi or Bluetooth. A growing number of innovative applications are possible, which are remotely monitored and controlled by LoRaWAN. Let's take a look at an example. There is finally help in searching for a parking space. Thanks to sensor-controlled parking space evaluation, a smartphone app can show the way directly to a free parking space. The parking space data is sent to our data center in encrypted and anonymized form via so-called gateways, which are installed throughout the city by Stromnetz Hamburg. Stromnetz Hamburg can forward the received sensor data to the user's own management portals for the purposes of managing and controlling the end devices. Hamburg is becoming a smart city of the future.
Hello, it's us with Hamburg's ITS projects explained in short. Let's have a look at digital parking management.
Hafen City, Hamburg's newest district. Innovative with a finger on the pulse of our times. This is where the research and development project HEAT is at home. HEAT stands for Hamburg Electric Autonomous Transportation. Hochbahn and other partners are testing the future of autonomous driving in the complex Hafen City test environment. What makes it special is that HEAT is one of the first projects in the world to implement autonomous driving in local public transport on a defined route without planned interference by a vehicle attendant. Electrically driven and safely in use in real traffic conditions. This is achieved by a combination of 3 subsystems. The vehicle with onboard sensors, support from roadside infrastructure, and monitoring by control centers. This composition considerably increases both safety and the flow of traffic. And this is how it works. When the HEAT vehicle receives its instructions from the control center, it independently and autonomously goes along the route at maximum speed of 25 km per hour. When the trip begins, the Hochbahn and Hamburg Verkehrsanlagen control centers are exclusively responsible for incident management. In other words, having the possibility to intervene in critical situations during operation, and for monitoring the decentralized sensor systems along the route. The vehicle operates on a 1.8 km long route with 5 stops. The doors open and close automatically at the stops. For barrier-free access, an additional ramp is lowered if required. Passengers have to register for a free trip in advance on the HEAT app. A vehicle attendant is on board during the entire duration of the project to intervene in the event of any malfunctions and to be able to help passengers if they have any questions. In the future, these tasks will be handed over to the control center on the one hand, and will be handled by the further development of the technology in the vehicle on the other. The minibus decides for itself when and where it can stop in front of obstacles, how it avoids other road users when it overtakes other vehicles, or when it crosses junctions. The onboard sensors with dual redundant 360-degree environmental perception provides the basis for these capabilities. Currently 5 radar devices and 8 laser scanners are used for this. Unlike many other autonomous projects, the HEAT vehicle is supported by a roadside infrastructure, for which radar and LiDAR systems and roadside units are also used. This way, real-time data is added to the environmental perception of the vehicle. This even makes it possible to look around street corners and behind parked vehicles. Communication and exchange of information between the infrastructure and vehicle is ensured through vehicle-to-everything standards. HEAT also communicates with the traffic lights and automatically interprets their status to safely cross junctions. The project is being accompanied by numerous passenger surveys. This way, the expectations people have of an autonomously driving transport system are to be precisely recorded. However possible, inhibition thresholds are also to be identified. Overall, the feedback was very positive, with important suggestions being made, among other things, on the possibility of communicating with the service point and on the general passenger information. Thanks to current changes in law, Germany is offering a promising environment for autonomous driving. Hamburg has been an important link in this development and has become a leading innovation center for new mobility and autonomous driving. As a result, the city offers a good platform for further projects and has a strong interest in developing and continuing corresponding business models. Hochbahn and its project partners see HEAT as an essential milestone to develop technological solutions to market maturity and establish autonomous driving to supplement existing public transport. HEAT, intelligent mobility for a future worth living.
The Hafen City is Europe's largest inner-city urban development and of pure innovative and standard-setting character. It expands the inner city by 40% and will provide approximately 45,000 jobs and 7,500 residential units for around 15,000 residents by 2030. But the innovation spirit also resides in the sustainable mobility concept. Everything can be reached by foot, by bike or public transport in a matter of minutes. That's why the Hafen City is called the City of Short Distances, or a 10-minute district. The need for your own car is drastically reduced, as well as the need for private and commercial parking spots. Above ground parking spaces are not built at all, and only 0.4 parking spaces per household are allowed in the underground garages. Even if you don't own a car, you can find a car sharing service in various private and in one public underground garage. A cohesive building-wide access system gives car sharing users access to all underground garages. The goal here is to adapt to individual needs. For this reason, the stations have a selection of different vehicles. Consequently, all users have access to 30 different underground stations. The system functions as a virtual garage combining 30 owners. Furthermore, at the time of commissioning, at least 60% of the fleet consists of electric cars. In order to save even more CO2 in the future, the amount of electric cars will be increased to at least 90%. The specifications for pre-fitting and equipping parking spaces for e-mobility were already integrated into the Hafen City Eco-Label building certification systems in 2017. On this basis, around 1,500 charging points are being created in private underground garages in Eastern Hafen City, and the system of car sharing is realised according to the finishing schedule of the city district.
Hello, it's us with Hamburg's ITS projects explained in short. Let's have a look at GeoNetBake.
In the city center area. Due to a construction site at the Ferdinandstor, buses will be diverted. Please note the valid diversions and the additional travel time.
LSA Plus is a unified overview of traffic lights and traffic flow in Hamburg. With this software, authorities can flexibly coordinate the green phases of traffic lights to reflect the current traffic situation. Let's say there is a road accident and the police have to shut down a lane to take care of matters. With the help of Traffic Jam Forecast, LSA Plus helps evaluate the optimal settings for traffic lights in the area. The data from LSA Plus not only can be used to make decisions, but also enables these decisions to be evaluated after the fact. Everything I just talked about will be combined in the upcoming project called #Transmove. Since there is so much data flying around, not all of it will be relevant for every use. #Transmove makes the relevant mobility data accessible and useful, whether you're a traffic control responsible, a city or traffic planner, or any everyday user. Thus, #Transmove will be the basis of all intelligent mobility decisions in the nearby and far future. As you've probably noticed, civil engineering requires a lot of collaboration between many actors, and coordination is always a challenge, not to mention the huge amount of bureaucracy involved. With all these digitization projects popping up, we're now able to streamline all the necessary steps into one workflow. And that's where Digital comes in. Digital provides an end-to-end process that seamlessly covers all the necessary requirements for civil engineering projects, all in one central place. Whatever role you have in the construction, the queue is identical. With smart infrastructure comes smart city planning.
Sieger in der Kategorie Ausblicke. Smala. Smarte Lade- und Lieferzonen. Wie können Liefer- und Ladezonen in deutschen Städten effizienter genutzt werden? Das will die Stadt Hamburg mit einem virtuellen Buchungssystem für Liefer- und Ladezonen erproben. Eine Sondergenehmigung macht den Test möglich. Für das System werden vorhandene Zonen mit Sensoren ausgestattet. Über eine App können beispielsweise Paketdienste oder Lieferanten eine passende freie Ladezone finden und reservieren. So kann die Parkplatzsuche und das Parken in zweiter Reihe vermieden werden. Der Verkehr wird dadurch emissionsärmer und sicherer. Reallabor Smala. Ausgezeichnet!
What you have witnessed is the project Bidirectional Multimodal Connection, or BD-Move for short. These boxes detect scheduled buses and give them priority at a light signal. So for this purpose, the traffic signals and buses are equipped with ITS components. Those are the sensors on the traffic lights. The onboard unit, OBU, installed on the bus continuously transmits information such as the bus line, route, speed, occupancy rate, and timetable situation, which is received by the roadside unit on the traffic light, RSU for short. In conclusion, that's why the bus traffic feels much smoother. Those are V2X infrared cameras, and they are part of the turn assistance project. A bus is a large vehicle, prone to blind spots, so through BD-Move's intelligent infrastructure, we can raise traffic safety. When the bus turns right, a hazard warning is calculated by two components. On one hand, you have those cameras detecting vulnerable road users, like cyclists or pedestrians, and they transmit a GPS position on their behalf using the ITS-G5 network. On the other hand, the bus in the area is able to evaluate this GPS position and calculate if a collision is imminent. If it is, then a visual warning is clearly displayed on the bus driver's instruments. For communication, the various standardized message types are sent via the ITS-G5 radio standard, which are encrypted via a public key infrastructure to maintain IT security. But, to get back at the first point, what also makes the traffic smoother is additional information displayed to the bus driver. Those include green and red light timers, the registration of the bus at the traffic light, or the remaining waiting time at the bus stop. We are living in an increasingly connected world, you know? Not only does everyone have a mobile phone, but traffic is becoming more and more digitized. We have it right when we say we are all connected. Never heard of it. Anyway, the project Connected Vulnerable Road Users is using this interconnection to make the road safer, more comfortable and more convenient for VR use. I can, for example, use the Gloucester app when I'm riding my bike to get to my destination more efficiently. This green light optimal speed advisory informs me of the green light phases on the traffic lights along my route. And whether I'm on a bike, on a scooter or on my feet, intelligent infrastructure will keep me safe. The collision warning app on my phone can predict oncoming traffic, keeping me safer on the road.